Let's think about time. How do we experience it? For most of us, the answer is intuitive. Time is like a great, endlessly flowing river. The past is the downstream region we have already passed, unchangeable and recorded in memory. The future is the mysterious upstream, an unexplored land toward which we are heading. And the present is the small boat of consciousness, being carried along on that current from a what was to a what will be. This feeling is the foundation for everything, for regret, for hope, for the very story of our lives. But what if this entire perception, from the river to the boat, is just an illusion? What if modern physics tells us that the distinction between past, present, and future doesn't really exist? That it is merely a persistent and convincing construct created by the human brain to interpret a completely different reality? Welcome back to Science for Sleep, where we explore the questions that shake the very foundation of our reality. In today's video, we will begin a journey into the nature of time. We will confront the shocking ideas from Einstein's theory of relativity, dive deep into the mystery of the arrow of time, and discover how our brain constructs the experience of time. Does time really flow? Or are we all just living in an eternal moment? Let's find out together. Let us begin with a simple observation, one so fundamental to our existence that we rarely stop to question it. The feeling that time flows. For us, time is not a static dimension like length or width. It is a dynamic process, a great, ceaseless current carrying us from the landscape of the past into the uncharted territory of the future. This experience feels as real and undeniable as the ground beneath our feet. The past seems fixed and unchangeable, a shoreline of memories we can look back upon. We can see the events that shaped us, the triumphs and the sorrows, with a sense of finality. We can remember that landscape, study it, and learn from it, but we can never physically return to alter it. The future, by contrast, feels open and unwritten, a fog on the horizon, a realm of potential and possibility. It is the direction toward which we feel we are moving, and where our choices seem to have real power to shape what is to come. And caught between these two realms is the singular, fleeting, and all-important moment of now. The present is the bow of the boat on this river of time, the only point at which we directly experience reality. We feel perpetually poised between what has been and what might be, carried forward by a current we cannot stop. This directional flow, this arrow of time, is the very scaffold upon which we build our lives. It is the source of our nostalgia and our regret, emotions entirely dependent on a fixed past. It is the foundation of our hope and our anxiety, feelings rooted in the uncertainty of an open future. Our entire narrative of self, our story of who we are, is written in the ink of this moving time, a sequence of events unfolding from beginning to end. This perception is powerful, intuitive, and universal. But what if this entire, deeply felt experience, from the flowing river to the boat of consciousness, is a profound and convincing illusion? What if the rigorous laws of physics, when examined closely, do not support this idea of a flowing river at all? What if they reveal a reality that is static and timeless, a universe where the past, present, and future are not fundamentally different? And what if our perception of time's passage is not a window into the true nature of reality, but is instead a sophisticated story, a user interface constructed by our own brains to make sense of a universe that is far stranger than we can imagine? This is the question that lies at the heart of our investigation. We will challenge our most basic intuition and confront the evidence that suggests our experience of time may be the grandest illusion of them all. For over 2 centuries, the universe ran on Newton's clock. Time, in the Newtonian world, was absolute. It was a single, universal entity, a great cosmic metronome ticking at the same steady rate for everyone, everywhere, regardless of where they were or how they were moving. 1 second on Earth was 1 second on Jupiter and 1 second in a distant galaxy. This was the bedrock of classical physics, a comforting and absolute truth that governed our understanding of reality. And then, in 1905, a young patent clerk working in Bern, Switzerland, named Albert Einstein, published a paper that broke this universal clock forever. This was his theory of special relativity, and it was built on a simple but revolutionary postulate. The speed of light in a vacuum is constant for all observers. This sounds innocent enough, but its consequences are profound. In our everyday experience, speeds are relative. If you are on a train moving forward and you throw a ball, its speed relative to the ground is the sum of your throw and the train's speed. But light does not play by these rules. If you are on a spaceship traveling at 99% the speed of light, and you turn on a flashlight, you will measure the speed of that light moving away from you at exactly the speed of light. And, astonishingly, an observer watching you fly past will also measure the speed of that same light as exactly the speed of light, not 199% of it. If the speed of light is absolute and unchangeable, then something else must be flexible to compensate. And that something, Einstein realized, is time itself. The faster you move through space, the slower you move through time relative to a stationary observer. This phenomenon is known as time dilation. This leads us to the famous twin paradox. Imagine 2 identical twins. Let's call them Stella and Tara on their 20th birthday. Stella embarks on a journey to a distant star in a spaceship that can travel at near the speed of light, while Tara stays on Earth. For Tara, life goes on as normal. She experiences the passage of time as we all do, year after year. Let's say, for her, 50 years pass. She ages, and she is now 70 years old. But for Stella, hurtling through space at close to light speed, time itself has slowed down dramatically. For her, the entire journey might have only taken 5 years of her own time. When she returns to Earth and steps out of her spaceship, she has aged only 5 years and is now 25 years old. She finds that her twin sister, Tara, is a woman. This is not science fiction. It is a proven physical reality, confirmed by countless experiments with atomic clocks on airplanes and satellites. What this paradox reveals is devastating for our intuitive notion of time. If 2 people can start at the same moment and then experience the passage of decades or mere years, depending only on their motion, then the idea of a single, universal now that everyone in the universe shares simply collapses. Your present moment and Stella's present moment are not the same. There is no single, flowing river of time for everyone. Instead, there are countless different timelines, each one valid for a different observer. Special relativity replaces the universal clock with a personal stopwatch for every single thing in the universe. But the assault on our intuition does not end there. Einstein himself would later show that it is not just speed that can bend and warp time, but the very fabric of space itself under the immense influence of gravity. Einstein's special relativity shattered the idea of a universal now based on motion, replacing Newton's single cosmic clock with countless personal stopwatches. But 10 years later, in 1915, he unveiled his masterpiece, the theory of general relativity, which revealed an even deeper and stranger connection between time, space, and the very structure of the universe. The theory began by reimagining gravity itself. For Newton, gravity was a mysterious force, an invisible rope that pulled objects toward each other across empty space. Einstein proposed something far more radical. Gravity is not a force at all. It is the shape of the universe, he asked us. To imagine space and time not as separate things, but as a single four-dimensional fabric called space-time. Imagine this space-time as a stretched rubber sheet. When you place a massive object, like a bowling ball, onto the sheet, it creates a deep curve, a dimple in the fabric. A smaller object, like a marble, rolling nearby, will not be pulled toward the bowling ball by a mysterious force. It will simply follow the curved path in the rubber sheet that the larger mass has created. This curvature, Einstein argued, is what we experience as gravity. But if mass and energy can bend space, and if space and time are part of the same unified fabric, then gravity must also bend time. This effect is known as gravitational time dilation. The deeper you are within one of these gravitational wells, like the one created by the Earth, the more space-time is curved, and the slower time itself passes for you relative to someone in a weaker gravitational field. A clock at sea level will tick ever so slightly slower than an identical clock placed on top of a mountain where gravity is marginally weaker. Your head, in a very literal sense, ages faster than your feet, though by an amount so small it is completely unnoticeable in our daily lives. Near the event horizon of a black hole, where gravity is immensely powerful, this effect becomes extreme. An observer watching an astronaut fall towards a black hole would see the astronaut's clock slow down dramatically, appearing to nearly freeze as they approach the edge. This warping of time is not just a theoretical curiosity. It is a daily, practical reality that the phone in your pocket likely relies on. The Global Positioning System, or GPS, works by using a network of satellites orbiting high above the Earth. Because these satellites are farther away from Earth's center, they are in a weaker gravitational field than we are on the surface. General relativity predicts that their onboard atomic clocks should therefore run faster than our clocks on the ground, by about 45 microseconds every day. At the same time, due to their high speed, special relativity predicts their clocks should run slower by about 7 microseconds per day. The net effect is that their clocks tick faster than ours by about 38 microseconds each day. If engineers did not build the GPS system to constantly correct for this relativistic time difference, the entire system would fail catastrophically. Navigational errors would accumulate at a rate of about 10 kilometers every single day. Fact that your GPS works, that it can guide you to your destination with pinpoint accuracy, is daily, tangible proof that time is not absolute. It is flexible, malleable, and dependent on the strength of gravity. So, Einstein's theories have delivered a 1-2 punch to our intuition. Special relativity shows that time is relative to motion. General relativity shows that time is relative to gravity. There is no single master clock, no universal river of time. Instead, reality appears to be a complex tapestry of interwoven space and time, a fabric that can be stretched, warped, and curved by mass and energy. This new picture of reality forces us to ask an even more profound question. If time doesn't flow universally, then what is it? What does this strange, four-dimensional fabric of space-time actually look like? If there is no universal now, And if the passage of time is different for every observer and every location in a gravitational field, then what is the true nature of reality? The logical conclusion that many physicists and philosophers have, drawn from Einstein's relativity, is a model of the universe, as strange as it is elegant. It is known as the block universe. In this view, our intuitive idea of time as a flowing river is abandoned completely. Instead, reality is imagined as a giant, four-dimensional block of space-time. This block contains every event that has ever happened and every event that will ever happen, from the moment of the Big Bang to the final, distant embers of the cosmos. Think of it like a reel of film. Every single frame of the movie, the beginning, the middle, and the end already exists, printed on the film strip. The story doesn't unfold as the film is made. It is already complete and unchanging. The action only appears to happen when a projector's light shines on one frame at a time, displaying them in sequence. In the block universe model, our consciousness is the projector's light. The universe, the entire four-dimensional block of space-time, simply exists, static and whole. Our awareness moves through it, illuminating one slice, one moment at a time. This moving spotlight of our consciousness creates the powerful and convincing illusion of a flowing now, and the sensation that the future is turning into the present, and the present is turning into the past. But according to this model, the flow is not a property of the universe itself. It is a property of our perception. The universe does not flow, we do. In the block universe, the distinction we make between the past, the present, and the future is not a fundamental feature of reality. It is an illusion, a product of our limited human perspective. The past is not gone forever. The dinosaurs, the Roman Empire, your own childhood, these are not erased. They are permanent features of a region of the space-time block that your consciousness has already passed through. Similarly, the future is not an unwritten, open realm of possibilities. It is a real, existing landscape within the block that your consciousness has not yet reached. Every moment of your life, your first step, the conversation you had this morning, the moment you are experiencing right now, and even the moment of your death, are all permanently and eternally etched into the fabric of space-time, existing simultaneously as part of this four-dimensional structure. This is a staggering and deeply counterintuitive view of reality. It replaces our familiar, dynamic world with a static, timeless crystal. It suggests that change itself is an illusion, and the future is as fixed and real as the past. But if this block universe model is the logical conclusion of relativity, it raises an immediate and powerful question. If the map of space-time is real and complete, why does it have a direction? Why does our consciousness only ever move in one direction along the map, from past to future? Why can we remember the past, but not the future? This is the great mystery of the arrow of time. If the future is as real and fixed as the past in a block universe, why can we remember one but not the other? Why does the river of our experience only ever flow downstream? This is perhaps the most powerful and intuitive objection to the idea of a static, timeless reality. Physicists call this deep puzzle the arrow of time. Strangely, when we look at the most fundamental laws of physics, from Newton's laws of motion to Einstein's relativity, and even the equations of quantum mechanics, they are almost all time-symmetric. This means the laws work just as well forwards as they do backwards. A video of a planet orbiting a star would look just as physically plausible if you played it in reverse. From the perspective of these laws, there is no inherent difference between past and future. no preferred direction for time to flow. There is, however, one powerful and famous law of physics that is not time-symmetric. It is the second law of thermodynamics, and it governs a concept called entropy. In simple terms, entropy is a measure of disorder, randomness, or chaos within a system. The second law states that in a closed system, such as the universe as a whole, the total amount of entropy will always tend to increase over time. Things inevitably move from a state of order to a state of disorder. Think of on a beach, it is a highly ordered and complex structure. It takes a significant amount of energy and intention to build it. But over time, the relentless action of the wind and the waves will inevitably break it down, scattering the individual grains of sand randomly across the beach. The sandcastle will never spontaneously reassemble itself from the scattered grains. The universe works in the same way. An egg can fall from a counter and break into a disordered mess. But you will never see the mess of a broken egg spontaneously leaped back into a perfectly ordered, whole shell. A drop of ink will spread out in a glass of water until it is evenly mixed. But you will never see the mixed ink particles gather themselves back into a single, concentrated drop. This relentless, one-way increase in disorder is what gives time its arrow. The future, according to this view, is simply the direction in space-time where entropy is higher. The past is the direction where entropy was lower. Our journey through the block universe has a direction because it is a journey from a state of low entropy order to a state of high entropy disorder. This also explains why we can remember the past but not the future. The act of forming a memory, whether in a brain or on a computer hard drive, is a process of creating an ordered record of a past event. This process itself requires energy and, in doing so, increases the total entropy of the universe around it. We can create ordered records of past, more ordered states. But to remember the future, a more disordered state, would be a thermodynamic impossibility. It would be like a broken egg leaving behind a perfect record of how it was going to reassemble itself. The feeling of time flowing forward is, in this sense, our direct perception of the universe obeying this fundamental law. It is the experience of witnessing the universe's slow, inevitable slide into chaos. So, the second law of thermodynamics provides a powerful physical basis for the arrow of time, explaining why we experience a clear and irreversible difference between past and future. But this elegant solution immediately leads to an even deeper and more profound mystery. If the universe is destined for disorder, why did it start in such a highly ordered, low-entropy state in the first place? We seem to have found a solid anchor for our experience of time's flow. The relentless increase of entropy, as described by the second law of thermodynamics. The universe as a whole moves from a state of order to a state of disorder, and our perception of time simply follows this one-way street from a more organized past to a more chaotic future. But in solving one mystery, we have uncovered a deeper and far more baffling one. The entire logic of the arrow of time rests on one crucial assumption, that the universe began in a state of incredibly low entropy, a state of profound and perfect order. If the universe is destined to become a disordered, chaotic soup, then it must have started as something akin to a perfectly arranged cosmic egg. An egg is a system of incredible order. All of its complex molecules are arranged just so, perfectly poised to develop into a new life. The universe, at the moment of the Big Bang, 13.8 billion years ago, seems to have been an egg of unimaginable perfection. All the energy and all the matter of the cosmos were compressed into an infinitesimally small, hot, dense, and remarkably uniformed state. This initial smoothness and uniformity represent an incredibly low entropy condition, the most highly ordered state the universe has ever been in. From a purely statistical standpoint, this makes almost no sense. There are vastly more ways for a system to be disordered than there are for it to be ordered. If you take a deck of cards in perfect new deck order and throw it in the air, the cards will land in a random, disordered state. If you throw them again 1,000,000 times, they will land in 1,000,000 different disordered states. The chance of them ever landing back in their original, perfect order is astronomically small. So, for the universe to have begun in its most highly ordered state possible is like throwing a trillion dice and having every single one of them land on the number 1. It is a state of such profound improbability that it demands an explanation. Physicists call this the past hypothesis, and it is one of the most significant unsolved puzzles in all of science. We have no definitive theory for why the universe was born with such an incredibly low entropy. Some speculative theories, like the multiverse, suggest that our universe is just one bubble among countless others. Perhaps most of these other universes are born into a high entropy state of thermal equilibrium, a heat death from the very start, and are therefore dead and unchanging. We, by necessity, find ourselves living in one oft incredibly rare universes that was born with the low entropy required for stars, galaxies, and eventually conscious observers to evolve and ask this very question. What this ultimate mystery means is that the arrow of time itself, the very thing that gives our lives a sense of forward momentum and narrative flow, is inextricably tied to this specific and highly improbable starting condition of our cosmos. The river of time flows because it began at the top of a very high and very unlikely mountain of order. It is not necessarily a fundamental property of reality itself, but a special feature of our particular cosmic epoch. We are living in the long, slow, unfolding aftermath of an initial state of perfect order that we do not understand. But the deepest levels of reality may be stranger still. What happens to our concept of time when we leave the grand scale of the cosmos and journey into the bizarre, probabilistic world of the quantum? We have journeyed through the vastness of the cosmos and found that our experience of time's flow, our arrow of time, seems to be a consequence of the universe's improbable, highly ordered beginning. But to seek the most fundamental nature of time, we must go deeper, past planets and stars, past atoms and their nuclei, into the strange and probabilistic realm of the quantum. Here, in the world of particles that can be in multiple places at once, that exist as clouds of possibility, until they are observed, the arrow of time becomes even more mysterious. The fundamental equation that governs this realm, the Schrödinger equation, is, like most other laws of physics, time reversible. A description of a quantum system evolving over time would look just as valid if you ran the mathematics backwards. The only part of standard quantum mechanics that seems to have a built-in direction is the controversial collapse of the wave function. The moment a fuzzy cloud of quantum possibilities resolves into a single, definite reality upon measurement. This process appears irreversible, but physicists still fiercely debate what it truly represents, and whether it is a fundamental process at all. The deepest challenge to time, however, comes from the quest to unite our two greatest theories of the universe: Einstein's general relativity, which describes the universe on the largest scales of gravity and space-time, and quantum mechanics, which describes the universe on the smallest scales of particles and fields. This hypothetical unified theory is often called quantum gravity. the holy grail of modern physics. In one of the most significant attempts to formulate such a theory, physicists Bryce DeWitt and John Archibald Wheeler developed a monstrously complex equation that attempts to describe the wave function, not of a single particle, but of the entire universe. And when you look at this Wheeler-DeWitt equation, a profound and startling feature emerges. The variable for time, t, is completely absent. It's not that time is relative, or that it is warped. In this mathematical description of reality, at its most fundamental level, time does not feature at all. The equation describes a static, timeless universe. How can this possibly be? How can a timeless reality give rise to the universe we experience? A universe that seems to be defined by its constant evolution through time. The proposed answer is that time may be an emergent property. Think of the concept of wetness. A single molecule of H2O is not wet. Wetness is an emergent property that arises from the collective interaction of a vast number of water molecules. It is real and meaningful at our scale, but it simply does not exist for the individual components. In the same way, some physicists believe that time itself is an emergent property. At the fundamental, quantum gravitational level of reality, there may be no time, only a static network of relationships between the components of the universe. But at our macroscopic scale, the statistical behavior of this timeless network gives rise to the appearance of a dynamic, flowing time. Time, in this view, is a feature of our scale, not the universe's most basic scale. This is perhaps the most radical idea we have encountered in our investigation. Not just that time is relative, or that its flow is an illusion created by entropy, but that time itself may not be a fundamental ingredient in the recipe of reality. If this is true, then where does our powerful, undeniable, moment-to-moment experience of a flowing now come from? If it is not a fundamental feature of the universe, either large or small, then perhaps we must look at the final piece of the puzzle, the remarkable biological machine that constructs our perception of everything, the human brain. We have journeyed to the very foundation of physical reality and found that time, as we know it, seems to disappear from the equations. This leaves us with one last place to look for the source of time's undeniable flow, the intricate, electrochemical labyrinth of the human brain. If the river of time is not a feature of the universe, then perhaps it is a story we tell ourselves. Unlike our eyes, which are dedicated organs for processing light, or our ears, which process sound waves, the brain has no single, centralized organ for perceiving time. Instead, our sense of time is a distributed process, a complex symphony played by many different sections of the neural orchestra. The cerebellum is involved in timing actions on the scale of milliseconds. The hippocampus is crucial for forming memories of events in sequence, and the frontal cortex helps us plan for the future. The experience of time is not a passive perception of an external reality. It is an active construction, a sophisticated narrative that the brain builds to make sense of the world. So how does it build this narrative? It does so by masterfully weaving together two of its most powerful abilities, memory and prediction. The feeling of a past, the sense that a moment has just slipped by, is entirely a product of memory. Your brain has an incredible capacity for short-term or working memory. It holds on to a constantly updating buffer of information about what just occurred. When you listen to me speak this sentence, your brain holds the beginning of the sentence in its memory so that the end of the sentence has context and meaning. It is this constant, fading echo of what just happened, this neural trace held for a few moments in your mind, that creates the powerful and undeniable feeling that a moment has just passed. The past, from a neurological perspective, is not a place you have left behind. It is a pattern of activated neurons in the present, a memory of a previous state. Similarly, our feeling of a future is a product of the brain's primary function as a prediction machine, based on every experience you have ever had and its innate understanding of the laws of physics. Your brain is constantly and automatically generating models of what it expects to happen next. As you walk, it predicts where your foot will land. As you listen, it predicts the next likely word. This constant state of anticipation, of waiting for the next moment to arrive and confirm or deny its predictions, is what we interpret as the future. And the flow of time, the seamless, continuous river we experience, is the brain's masterful trick of stitching these two processes together. It seamlessly weaves the fading echo of memory with the emerging model of prediction, creating a smooth narrative centered on the illusion of the now. The present moment is simply the point at which new sensory data arrives, is compared to the brain's predictions, and is then immediately encoded into short-term memory, becoming the new past. This is why our subjective sense of time is so malleable. When we are in danger, the brain increases its rate of information processing, creating more distinct memories per second. And, in retrospect, time seems to have slowed down. When we are engaged in a new and exciting activity, we are forming rich, detailed memories, and time feels full and elongated. When we are bored or in a familiar routine, the brain operates on autopilot, forming fewer new memories, and time seems to speed up and fly by. The river of time does not flow through the universe. It flows through our minds. It is a neurological construction, a beautiful and convincing story. But if our experience of time is a story, and the order of events in the block universe is fixed, what does this mean for the concept that holds our world together, the fundamental idea of cause and effect? We've arrived at a picture of reality where the flow of time seems to be a product of our minds, and the universe itself may be a static, four-dimensional block in which all moments exist simultaneously. This idea is so radical that it seems to threaten the most fundamental principle of logic and science, the law of cause and effect. If the future already exists, just as the past does, how can we say that an event in the past causes an event in the future? Doesn't causality require a before and an after that are fundamentally different? If the entire film reel of the universe is already printed and complete, does that mean the explosion we see on screen isn't truly caused by the fuse being lit in an earlier frame? Are they not just two separate, coexisting images? This is a profound and important question, because a universe without causality would be an incomprehensible chaos, a world where things happen for no reason at all. The resolution to this puzzle, however, lies in making a crucial distinction between the flow of time and the order of events within time. We have established that the subjective flow of time is likely an illusion created by our consciousness. However, the order of events along the time dimension is a real, objective, and fixed property of the space-time block. Let us return to the analogy of a map. The city of Los Angeles is, and always will be, west of the city of New York. This is a fixed, unchangeable spatial relationship based on their coordinates on the map. The fact that a person might travel on a journey from New York to Los Angeles, experiencing one after the other, does not change the fixed spatial order of the cities themselves. In the same way, on the four-dimensional map of space-time, the event of the Big Bang is located at a time coordinate that is before The event of the formation of the Earth. The formation of the Earth is before the age of the dinosaurs. The age of the dinosaurs is before your birth. These are fixed, unchangeable coordinates along the time axis. Causality in the block universe is not a dynamic process that unfolds in a flowing present. It is a static pattern woven into the very fabric of space-time. The pattern of an effect always appears at a time coordinate that is after the pattern of its cause. The lit fuse is at an earlier time coordinate than the explosion. The two events coexist within the block, but their relationship, their sequential cause and effect order, is a permanent and unbreakable feature of the pattern. This causal structure is rigorously protected by the laws of physics. Einstein's relativity dictates that nothing, no information or influence, can travel faster than the speed of light. This creates what physicists call a light cone for every event in space-time. An event can only be caused by things that lie within its past light cone, the collection of all points in space-time that could have sent a signal to it at or below the speed of light. And in turn, that event can only cause other events that lie within its future light cone. This structure ensures that even in a static, timeless block universe, you cannot have an effect without a prior cause that lies in its causal past. The orderly pattern of if this, then that is perfectly preserved. So, the block universe, while eliminating our intuitive flow of time, does not eliminate the logical structure of causality. The universe is not a chaotic jumble of random events. It is an intricate crystal, a perfectly ordered tapestry where every thread is connected to the next in a logical and unbreakable sequence. The story may already be written, but it is a story that makes sense. A story where every event has its proper, causal place. And with this final piece of the puzzle in place, we can now step back and ask, what does all of this mean for us, as conscious beings living out our lives within this strange, beautiful, and timeless reality? So, we have arrived at the end of our journey with a new picture of reality that is both bizarre and beautiful. We began with our most basic and powerful intuition, the feeling of time as a great flowing river carrying us from a fixed past into an open future. We saw how Einstein's relativity shattered this notion, breaking the universal clock and showing us that the passage of time is a personal experience, relative to our speed and the strength of gravity around us. This led us to the staggering concept of the block universe, a static, four-dimensional reality where past, present, and future all exist simultaneously and are equally real. We then searched for the source of time's forward motion, the arrow of time, and found it not in the laws of motion, but in the relentless second law of thermodynamics, the universe's inevitable slide from a state of perfect order into one of ever-increasing chaos. Journeying to the most fundamental level, we glimpsed a quantum reality where time itself may not be a basic ingredient, but an emergent property of our macroscopic world. And finally, we discovered that our powerful, moment-to-moment experience of time's flow is a masterful construction of our own minds, a seamless story woven from the neural threads of memory and prediction. What then are we to make of all this? If the river of time is an illusion, is our life meaningless? The answer, many philosophers and physicists believe, is a resounding no. The universal, flowing river of time may indeed be a grand illusion, but our experience of sailing upon it, moment by moment, is not. It is the only reality we will ever know, and it is profoundly real and meaningful. This understanding does not need to devalue our lives. On the contrary, It can imbue the present moment with an even greater sense of preciousness and significance. If the past is a fixed landscape and the future is also a fixed landscape, then the only place where our consciousness resides, the only place where experience happens, is in the moving spotlight of the now. The present moment is not just a fleeting point between an erased past and an unwritten future. It is the very window through which we perceive a timeless reality. This perspective invites us to let go of our regrets about the past, which is an unchangeable region of the space-time block, and to release our anxieties about the future, which is a region that already exists. It encourages us to place our full attention on the richness, the texture, and the beauty of the present moment, the only place where life is truly lived. You are not just a passive traveler on a river. You are a conscious slice of a reality. You are a perspective through which the timeless universe becomes aware of itself. Your consciousness, as it moves through the block universe, is the very thing that creates the story, the flow, and the meaning. The universe may be a static, silent crystal of space-time, but your experience of it is a dynamic and beautiful song. And with that thought, perhaps we can find a sense of peace, a quiet acceptance of our place in this strange and wonderful reality. A reality where every moment is, in a very real sense, eternal.